Good morning, class. I am Ma'am Patricia Abigail P. Perez, and I will be your teacher for today in our topic called Light, Physics subject. So for you, what is light? I think you will answer me, Ma'am, light is what we visualize every time we open our eyes or kung ano man yung mga nakikita natin sa mga instruments na ginagamit natin para gawa lang ng light para ma-visualize natin yung mga objects or surroundings kung nasa madilim na lugar tayo. But in physics, there is a meaning of light. So, here's our objectives. First objective is define what is light. What is the meaning of light in physics? Then discuss the characteristics of light. Its characteristics, brightness, intensity. Next, colors. Discuss the different light colors. The 7 light colors of light. Itatakal natin ang lahat ng ito later on. So now, let's proceed to our topic, light. So what is light in physics? So light in physics is, it means, let me read the text on this slide. In physics, the term light sometimes refers to electromagnetic radiation of any wavelength, whether visible or not. In this sense, gamma rays, X-rays, microwaves, and radio waves are also light. So as you can see sa slide, electromagnetic radiation is mentioned. What is electromagnetic radiation? For sure, you will itatanong nyo yan kung ano ang electromagnetic radiation. So let me read it. Ninote ko talaga siya para hindi ko makalimutan. When you said electromagnetic radiation, it describes fluctuations of electric and magnetic fields transporting energy at the speed of light. Here, as the slide mentioned, as I mentioned on this slide, why that gamma rays, X-rays, microwaves, and radio waves are also light. What do you think is the reason? Let me share the reason now. Because these 4 names mentioned in this slide are several parts of what we call electromagnetic spectrum. Take note, electromagnetic spectrum outside the visible. So despite these 4 names are variety of names, are all forms of light. Here. Next slide. So after we define what is light, now let us proceed to the characteristics of light. So first, we will tackle the intensity and or brightness of light. So as you can see the picture here, this row is bulb type and the lumens below it, the rated life and savings. This standard bulb has, if it have 40 lumens, have 40 watts. Same in halogens 29 when 450 lumens, CFL 9 watts, 450 lumens, and LED 6. Same as in 800 lumens, 60, 40, so on and so forth. Next, rated life, kung gaano sila katagal na magagamit. Kung the standard has 1 year, halogen 1 to 3 years, CFL 6 to 10 years, and lead 12 to 25 years. Sa pinakababa is savings, kung ilan yung mga mas-save natin kung ito yung mga ginamit nating mga bulbs. Sa standard, no savings. Halogen, up to 30% savings. CFL, up to 75% savings, and lead, up to 90% savings. Next, the second picture is, as you can see, curves have different light colors. Here, as you can see, the 10, 20, 30, and so on and so forth, this is the percent of sensitivity of light. And at the bottom, 400, 500, 600, 700, and so on and so forth, are the nanometers of the light here. Next. So now we will go to tackle the intensity and brightness of light. Let me read the first bullet. Intensity is the power per unit area. It is a physical quantity, while brightness involves how the human visual system perceives light and not a physical quantity. So what does it mean? Intensity and brightness has a difference. When we said intensity, it is the physical quantity, while brightness is visual system perceived light. In intensity, mentioned on this slide, it is the physical quantity. What do we call about, ano ibig sabihin, if it is the physical quantity? What do you think is the reason? The reason is physical quantity means it is the properties of light, like wavelengths, amplitude, including intensity of light, and so on and so forth. That is what we call properties, physical quantity. When we say brightness, meaning why it is the visual system perceived light, not the physical quantity. What do you think is the reason? So let me read the reason. When light hits the retina of our eye, the inner part of the human eye, special cells called photoreceptors, take note na, special cells named photoreceptors, turn light into the electric signals. These signals travels from our retina, the inner part of the human eye, through optic nerves. The optic nerves is the nerves in our eyes, travels para mapunta sa brain natin yung kung anong brightness ng light. Next, let me read the second bullet. Alternative title for light intensity is luminous intensity. Take note of the luminous intensity, the quantity of visible light, and that is emitted in unit time per unit solid angle. The unit for the quantity of light flowing from a source in any 1 second is called lumen. So what does the second bullet mean? So let me read. When we said luminous intensity, it is a measure of wavelength wave, power emitted by a light source by a particular direction per solid angle. based on the luminous function. Lumen means it is evaluated with reference to visual sensation. So, it is the unit for quantity of light flowing from a source. Next, let me read again the third and last bullet. Brightness of light determined by the color or hue of light depends on its wavelength. The distance between the peaks of each wavelength. Next, brightness of light is related to intensity or the amount of light and amplitude, the height of light waves. What does it mean? Let me read again. Brightness is also somewhat influenced by wavelength. Example of this is yellow light. Yellow light is brighter compared to red light and blue light. Why? What do you think is the reason why yellow light is brighter than blue light and red light? Why? It's because amplitude affects brightness. Amplitude of waves tells about the intensity or brightness of light waves in the same wavelength. The wavelength of light is important property to determine the nature of light that what we visualize in our human eye. Next slide. So, we are done on the characteristics of light. So, now we will proceed to the colors of light. We have 7 colors of light, namely red, violet, blue, green, indigo, orange, and yellow. Later on, we will tackle these 7 colors in our following slides. So how do we determine color of light? What do you think? I know you will answer na, Ma'am, kung ano po yung nabivisualize ng mga mata natin, madidetermine po natin kung anong kulay ng light ang mga yon. So, in physics, there is a reason, meron tayong pagbabatayan para ma-determine natin ang color ng light. So, let me read the text on the slide. The wavelength of visible light determines the color that the light appears. Light with the longest wavelength appears red, and light with shortest wavelength appears violet. The wavelengths of visible light that an object reflects or transmits determine the color that the object appears to the human eye. So meaning, the wavelength will determine the light colors. It depends if the wavelength is long or short. If the wavelength is longer or longest, it is the red light. And if the wavelength is shortest or shorter, it is the violet light. So visible light, it is the light that has wavelengths that can be detected by the human eye. The wavelength of visible light determines the color that the light appears. So, it is the visible light that determines the color that light appears. Next. So, before we tackle the different light colors, let us determine first the instrument to measure light colors. Sorry if hindi na ako nakapag-input ng picture dyan para may pakita ko sana kung ano yung itsura itsura ng instrument na ginagamit to determine light color. So, the instrument used for measuring light color is what we call spectrophotometer. Spectrophotometer, which takes measurements in the visible region of a given color sample. So ito yung ginagamit nila para i-determine yung light color. Clear? So now, let us tackle the different light colors. First, the red light. Let me read the first bullet. Color of light has lowest energy. Color has lowest frequency. What do you think is the reason why red light has the lowest energy and frequency? So here's the reason. Light has lowest energy and frequency because red light has the longest wavelength. The long wavelength, the energy and frequency is low. Take note of that. Long wavelengths, low energy and frequency on it. Next is the color of visible white light that travels fastest in the medium. What do you think is the reason why red light is the visible white light that travels fastest in the medium? What do you think is the reason? So the reason is the red light has the maximum velocity of light when it passes the medium. Hence, the color of white light travels fastest in the medium. That is the reason why red light is a visible white light travels faster in a medium. Next, violet light. Now let's proceed to violet light. Color of light has highest energy and has the highest vibration and shortest wavelength of visible light. So compared to red light, violet light has shortest wavelength, unlike in red light has its longest wavelength. What's the reason? So here's the reason. Violet light has shortest wavelength of the visible light spectrum. So violet light can carry most of energy. So the shortest wavelength, more energy can carry of it. Next, violet light has shortest wavelength. Therefore, ultraviolet light is the highest frequency in the frequency is color violet. So violet light has highest frequency because ultraviolet light has highest frequency. Although, because ultraviolet light is a violet light. Next, blue color. Let me read again. The hardest color to see as more light energy is required or for a full response from blue-violet cones compared to green or red. Why? What do you think is the reason? Because, let me elaborate to you. Because blue light causes more trouble. It causes trouble to the human eye than other colors. That is because it is harder for eye to focus blue sharply. So maybe our eye, if we focus directly to the blue light, maybe our eye will get damage on it. Rarest color in nature. Why that blue is the what we call rarest, very rare color in nature? Here's the reason. Less than 1 in 10 plants have blue flowers. Yes, meron talaga mga plants na blue ang flowers nila, pero parang bibihira lang din. And far fewer animals are blue. Far fewer man. Siguro. Meron siguro mga animals sa color blue, pero konti lang siguro or maybe wala talaga eh. Pero ako personally, never pa ako nakakita ng animals na color blue. Pero siguro wala dito sa bansa natin or other countries, meron silang mga animals sa color blue or pwede din meron dito sa country natin pero in different Pero uh, sa ibang lugar, sa ibang city, or mga, basta something like that. So the reason is that there isn't really a true blue color or pigment in nature, and both animals and plants have to perform tricks of light to appear blue. So, para maging blue rin kasi ang isang plants or animals, kailangan nilang mag-perform ng trick para maging blue sila. Like the rose, the flower rose, walang blue na rose, pero meron silang ginagawa, yung mga flower shop, meron silang ginagawa, pag gusto ng isang customer nila, is blue rose ang iregalo nila sa kanilang mga minamahal, sana all. Pero joke lang. Meron silang ginagawa, parang kinukulayan nila para maging blue yung isang rose, kasi alam naman natin na walang color blue na rose, diba? So that's it. Blue color that causes retina. So ito na yung na-mention ko dati ay kanina. Because meron isang study na na-discover nila na ang blue light is nagre-release ng toxic molecules in photoreceptor cells. So yung blue light pala is nagre-release siya ng mga toxic na photoreceptors molecules na pwedeng makapag-damage sa mata natin, na pwede tayong mabulag or whatsoever. Example of this is LED. So masama sa mata natin ang LED kung na-overuse ang LED sa atin. Next light color is the color green. The green is the color that attracts the human eye most. Why? Because siguro ang reason is siguro malamig siya sa mata, kapag tinitignan mo napakalamig, napakaganda, napakaliwanag, siguro kaya it attracts human eye most, di ba? Lalo na pag bright green, kasi ang dami ko i-encounter na mga tao na favorite talaga nila ang color green, lalo na pag bright green talaga siya, kasi napakaganda talaga ng bright green, like this one. Gusto ko rin ang green, pero parang side lang yun. Next light color is indigo. Indigo is a rich color between blue and violet on the visible spectrum. Why indigo called the rich color between blue and violet? Maybe it is because it is a combination of blue and violet colors. Pero meaning it is a dark purplish blue. Dark purplish blue siya. Kung makikita niyo siya sa electromagnetic ay sa visible spectrum. Kasi hindi naman talaga primary color itong indigo. It's the combination of two colors talaga. Next, orange can be strident and exhausting if it's overused. Orange color with danger and its attention-getting properties means most designers use it. So parang blue color din siya na nagko-cause ng damage sa atin, lalo na sa mga mata. Because orange is between red and yellow light. Too much use of orange light is overpowering. Take note of this, overpowering. And can cause danger when it's overused. So parang yung blue color din siya. Blue color of light na nagko-cause ng danger sa ating mga mata. Next, yellow light. Ito yung last na color ng light. Is the color between orange and green on the spectrum of visible light. So kung titignan nyo yung spectrum, yung color yellow is nasa gitna ng orange and green light. Because why that yellow light is between orange and green? So here is the reason. Yellow light has its shorter wavelength than the green light and are longer and Yellow light has its shorter wavelength than the green light and longer wavelength than orange light. So this is the reason why the yellow light is between the orange and green on the visible spectrum. So that is our discussion for today. Before we end this discussion let me give you an evaluation. Before pa lang ang ating evaluation I think that marami kayong mga gustong itanong pero this is a virtual presentation or demo teaching. Hindi ko siya masasagot talaga here in virtual. Pero habang ginagawa ko tong slide na to, merong nagtanong sa akin. Sabi niya, ang tanong niya what color do you see if an object absorbs all of the light that strikes it? Wow, ang ganda ng tanong niya. So, I think, nung narinig ko tong tanong na to parang kuha niya yung attention ko, parang naganda na ako sa tanong, kaya I choose this question as a short generalization of our topic. So here's the answer now sa tanong na ito. When all of the light is absorbed, none is reflected. Wala nang magre-reflect. So that the object looks black. So wala nang magre-reflect. Pag na-absorb na lahat ng light, kung yung object is na-absorb na lahat ng light, wala nang light na magre-reflect. So ang reflection na ng object is magiging black na. Pero ang black is not a color of light. It is the absence of light. So meaning, pag na-absorb lahat ng light na-absorb ng object lahat ng light, meaning magkakaroon na ng absence of light pag nangyari yun. Ganun yun. Clear? So now, before we end, magbibigay muna ako ng evaluation para sa ating topic, kung meron nga ba kayong natutunan or wala. Kung meron man. So, I prepared 10 questions. I will read the questions and ako na rin ang magsasagot because nasa recording demo teaching or presentation. So, first, it refers to the electromagnetic radiation of any wavelength, whether visible or not. The answer for this is light. Second, it involves how the human visual system perceives light and not a physical quantity. The answer for this is brightness. Third, which takes measurements in the visible region of a given color sample. The answer for this is spectrophotometry. Fourth, what light color that can be dangerous to the human eye. The answer for this is blue light. Fifth, is the unit of the quantity of light flowing from a source in any one second is cold. The answer for this is lumen. 6 and 7, nagkaroon ako ng typographical error dito. Naging parehas yung tanong sa 6 and 7. So, babasahin ko na lang yung number 6 question at i-disregard ko na lang yung 7 kasi same din naman sila ng tanong. It involves how the human visual system perceives light and not a physical quantity. The answer for this is brightness. Same din sa number 7 ng sagot, brightness, kasi pares lang naman sila ng tanong. 9. Light travels in waves and is only form of blank visible to human eye. Fill in the blanks. The answer for this is energy. Light travels in waves and is only form of energy visible to human eye. 9. The color of light has the most energy. The answer for this is violet light. And last, what are the 3 primary colors of light? The answer for this is red, green, and blue. And that's all. Now, experiment tayo. Light or cool refraction experiment. So, hindi natin siya may papakita ngayon kasi nga hindi natin siya may perform ngayon kasi nga nasa recording demo teaching tayo or virtual presentation. So, ipapaliwanag ko na lang siya. This is the overview of the experiment. This experiment might be one of the most easiest to do in science experiments. It's a bit tricky to explain but impressive even if you can't quite get your head around it. So, simple lang siya. Pwede nyo siyang gawin mag-isa, pwede nyo gawin sa bahay, kahit hindi nyo nagawin dito sa school. Madali lang naman siya. Pati yung mga requirements niya, easy lang. Makikita nyo lang sa mga bahay-bahay niyo yung mga materials nito. Objectives: introduce and give some background of the experiment. Demonstrate how light refracts in water. Show what will happen in the experiment. Next, materials that we need. First is bond paper, marker, ball pen, glass, and water. So, tingnan nyo, maano lang siya, madali lang siya. So, kaya nyo itong gawin mag-isa kahit nasa bahay lang kayo. Next procedure, get a sheet of bond paper and draw 2 arrows on it using marker or ball pen. 1 arrow near top and 1 arrow near the bottom. Make the arrows point in the same direction. So first procedure, kuha kayo ng bond paper and mag-drawing kayo ng 2 arrow na nakaturo sa isang direction. Next, fill a glass with water, but make sure the glass or your plastic cup is transparent and clean. So, dapat yung glass na gagamitin nyo is transparent talaga siya. Hindi siya malabo, walang kahit anong prick para makita yung object na ilalagay ninyo doon sa likod ng ng glass pag nilagyan nyo na ng water. Third, slowly put the piece of second, fill the glass with water plastic cup but make sure the plastic cup is transmitted and plain. So, dagdag pa dito is dapat yung ilalagay ninyong tubig sa inyong baso is clear. Walang kahit ang dumi or walang food color para makita nyo rin yung object na ilalagay nyo sa likod ng inyong glass of water. Third, slowly put the piece of paper behind the glass of water but make sure it is transparent to fully visualize the arrows clearly. So, gaya ng nasabi ko kanina, dapat clear yung tubig para makita. Kapag nalagyan nyo na ng tubig yung inyong glass of water, dahan-dahan yung ilagay yung bond paper na dinrawingan nyo ng 2 arrows doon sa likod ng inyong glass of water. And last, look and observe through the glass of water and watch what happens. So, pagka lagay nyo dun sa likod ng inyong glass of water, yung inyong bond paper na dinrawingan nyo ng 2 arrows, observe nyo na kung anong mangyayari dun sa arrow, kung mag-change ba siya ng directions, or mag-i-enlarge, or whatsoever, basta ganun. Observe nyo lang. So, that is the end of our discussion for today. I hope you learn and you gain new knowledge about the light topic. Thank you and God bless.